Okay, let's get started. So, as mentioned before, my name is Lordrick Kahinga. I'm a third-year PhD student. Like everybody to open their Jupyter notebooks. That is if you have installed all Conda and all the other required software plus the PyaR notebooks. If you have not yet successfully installed it, once again, don't worry. There will be mentors to help you with that. I was thinking about it in breaks, but probably after the session would be the best time. And so while I'm doing this, while I'm sort of yapping around for the moment, you can try and open the Jupyter notebooks. All right, so these are my Python essentials. Like I said, I am kind of semi self-taught because I had the one workshop, so I was kind of taught, but I kind of picked up a lot of things along the way. These are the three things you need to learn if you want to use Python for science. You want to learn the data structures. That's the lists, the arrays, the tuples. We're gonna see a lot of those today. The dictionaries and all these things. Once you know these few things, you have the very basic, but this is a very good start. After you know that, you want to learn conditional statements and loops. Conditional statements are essentially telling the computer, do this when this is happening, or do that when this happens. And then we also like computers because they can do things over and over and over again without getting tired. You want to do sometimes in science, you want to do something a billion times. You want to do something a million times. It would be very hard to do it by hand or using a calculator. Computers are really good at that, and so you want to learn loops. Once you have Python data structures and loops, you then want to to broaden that, you need to learn functions. And functions are basically just when you want the computer to remember what you're telling it to do. And then you'll have libraries, which are basically functions that people have made for specific purposes. They've spent a lot of time making these codes. We'll see a lot of those today as well. You want to use functions that are used in visualization, so making plots and all those sort of things. Once you know those libraries, and then there is this one thing here that's called object-oriented programming, which I will leave as a homework for all the people that are here in the tutorial. Just go and look this up after you're done with this entire Python session. That's today and tomorrow. It's a really, really cool thing. Once you master all these things, I want to tell you that you will be on a very good standing in terms of using Python for science. And the good news is we're going to learn a lot of these things today. Maybe not object-oriented programming, but most of the other things we're going to cover today and tomorrow. In those sessions, we will see them in action. So you're in good hands. This is a very, very good start and it's a very good investment for your career as a scientist. So let's dive in. Okay, now, where's my notebook? So hopefully everybody has opened their Jupyter notebooks and they can kind of see these three folders. I'm gonna once again give people about 60 seconds to see if they can get here. All right, thank you. So those who have successfully got here, there's gonna be three folders that you're gonna be working with through this entire workshop. There's a data one, which essentially has real, oh, sorry, that was too fast, which has real astronomical data. Let me close this again. I think I'm clicking too fast. One second. Okay, yes. Here inside data, we have some data files, which these are real data collected by astronomers, which you're going to be using. We're not going to be using this for the first two notebooks, but we will use it later in other notebooks to actually do actual science with this data. And then there is a plot where we're gonna be saving our plots. We're gonna making a bunch of figures to understand our science more, and they will be saved in this directory. But for now, I want you to go into your programs directory and then go into the first notebook that says Python intro. And you should see something that looks like this. Now, a quick note, if you are following along, I would like you to sometimes there's usually already solutions inside the notebook. So when I say solutions, I mean there's some answer here. So for example, you see it's already printed the word hello world here. So if that is the case for you, I want you to click kernel here and essentially just clear all outputs because I don't want you to see the answers and ruin the surprise. And so you want to clear all. So you restart kernel and clear. It will prompt you to restart here, and you will be set to go. This is has kind of been the classic one for scientists, at least in the last 10, let me say 12 years. No, 17 years, because it's really user friendly. It's not a super complicated language, and you can really do a lot of science with it. And if you want to read a lot about Python, there's a link here called Python .org. You'll learn a lot of things about Python there. That's where you find everything about Python. And then there's a lot of tutorials, general tutorials about Python here. I actually didn't see this before. I just mentioned object-oriented programming. I didn't know it was here in the link. Yes, if you want to learn a lot about object-oriented programming, which I was just mentioning in my slides a few minutes ago, here is where you will read a lot of, yeah, it once again, the name sounds very intimidating, but it's not really. It's a great skill set to have. And then you have this thing called Stack Overflow here. That's uh that's where we go. Essentially, it's think of like Facebook, but for Python. It's where we ask and post all the questions that we have in Python, and we get to get our solution. And there's people who have used Python for long periods of time, and they'll have solutions written over there. So this is essentially where we go when we have questions about Python. You just type in your question, and there's gonna be a related question or your exact question because these kinds of issues that people get stuck with are very common, and so you'll find a lot of answers in Stack Overflow. Now, we're in the edge of AI, and so AI can be a great tool. Now, AI is fantastic. I'm gonna say that. So, if at all Stack Overflow has not been helpful for you in figuring out the answers to your question, you can use AI. But I want to caution you. While AI is super useful, it can also make you not learn or not grow the programming muscles that you need. And so AI is really good. It can write you your entire code, but if you have not spent the time, if you've not put in the reps, if you're not putting in the works exactly to learn the skills, you will not understand what AI is giving you, so all the chatbots, and they make a lot of mistakes. I use AI sometimes. Sometimes I even get mad and not use it because it makes a lot of mistakes. So do not trust it completely. But in order to be able to understand what AI is giving you, you need all these skills. And so do not neglect the skills right now just because we have AI. But it can be a great tool. I can say one thing when I use AI and it's something I don't understand. So, for example, it's a language maybe I don't use, like JavaScript or something like that. I ask it to, before it gives me the code, to explain every single step. And then I will write the code on my own. That is actually a better way to use AI. So I encourage you to use AI, but be very cautious. First, learn the skills, and then you can go into AI as you may please.
Thank you
And
so
now,
much,
yeah.
Lordrick, for
Mhm.
speaking to that point
Mhm.
about AI because it's so very important to reaffirm how critical it is to have the foundational knowledge in order to use those tools like AI in helping with your programming. You have to know the alphabet before you can make sure that the AI is spelling your words correctly.
Yeah.
But thank you
Yes.
for that.
Mhm.
I
Mhm.
actually
Mhm.
just had someone
Mhm.
send me a quick message about using AI if we were going to demonstrate that. So we will not be demonstrating how to incorporate using AI in these tutorials. But as I was talking with Lordrick and Geronimo and Bojidara before we got started, we will be doing an overhaul of this program and in order to incorporate some new things like potentially a portion on AI. All right. Thanks, Lordrick. Please
Thank
continue.
you. Thank you. Now we get into kind of the fun thing here. That's the thing you're opening right now is called a Jupyter Notebook. You may have written down that thing in your terminal somewhere when you were studying this notebook, but I want to kind of talk about it a little bit. There are many ways to run Python, but Jupyter Notebook, especially for beginners, is one of the best ways. And that is because it allows us to run the code in pieces. And so you'll see what I mean in a second. Uh, what Jupyter Notebook essentially has is what these things are called cells. So this whole thing here is written in a cell, and this other thing here is another cell, and this is a cell. And so essentially you can run something in a cell. A cell is essentially that's a little piece of the entire canvas of the notebook, where I can just run my program there and it will execute and give me what I need to see. The good thing about there are a lot of good things about that. One of them is we can add beautiful text like this, uh, if we're doing tutorials like so, or even if when you're writing your own code. This text is super important to kind of explain what the code is doing. And let me go over this really quickly. It's super important to explain what your code is doing. A lot of the time it is for you. I cannot tell you how many times I've written code, and if I don't document well, I'll come back a few months later and I don't know what my own code is doing. And I wrote the code. And yeah, you can think like, how can I forget? When you write a lot of code, you'll forget what your code is doing. So we always want to explain what the code is doing. And Jupyter Notebooks are really good at that because we can have this kind of explanation. We can even have beautiful figures like this. But also we have these kinds of cells where we can run code. And so that is the wonderful thing about Jupyter Notebooks. So please, I encourage you to keep using Jupyter Notebooks, and then maybe with that overhaul, maybe someday we'll show how to use other things like modules and all these other things. But for now, we'll be using Jupyter Notebooks. And so let's get into it. We're gonna start with the very first thing that we do in programming, and that is using print or the print function in Python. Now, why do we need the print function? Because whenever we run code, whenever we are doing things, we want to see the results. So it's essentially like in your calculator. When you add two numbers or you do whatever you want to do, you want to see the answer. I don't think anybody would use the calculator if it does not have a screen. And so the print statement is essentially that. This is how we see what is going on. And so in any classic programming tutorial, the first thing we do is we print hello world. Now, I don't know why we print the words hello world, but it seems to be the norm. And so we're gonna go with that. And so what you can see here, if you want to print something, you write the word print. This is what is called a function. It's one of those functions that we'll talk about a little bit later. And we put parentheses in them. And in those parentheses, you see we have something written down here, which has two of these quotation marks. If you see anything that is surrounded with these two quotation marks in Python, it is what we call a string. And that will be our first data type that we are learning, okay? So this string here, we cannot print things that are not strings in one form or the other. So a string is basically just words that we see. And so we can see here we have hello world inside these two quotation marks, and that's our string. And if I run this cell now, how to run this cell? You can press Control on your keyboard and press Enter. Well, usually there's a button here. I don't see it at the moment. Move the cell up. Oh, I think they've made a new kind of Jupyter Notebooks. We used to have a play button there. Oh, or you can use this one, but this will run all. But here is the thing. Yes, the
Oh,
easiest way would be to click Control or Enter. I don't know. Maybe there's people who have used these new Jupyter Notebooks. Can I just play here? Oh, yes. Yeah, I
yes,
can also
play.
press play
Yeah.
here. Yes.
You got it.
Yes, I don't use Jupyter Notebooks a lot because I use I use modules most of the time. That's why I forgot about that a little bit. Yes. But if
Perfect.
you click play here, and you can see now we have the words hello world. Okay? So great, you've run your first function. You've run your first function in Python. By the way, we can do anything else. And so let me do a little bit more examples here. And so I can comment that out. And commenting that out means we're not gonna run this line. And so you just had a hashtag in front of this line. And so we can print something else. I'm gonna copy that. Let me put something else inside the string and say, I don't know, maybe PyaR workshop 2025. And once again, if I run that cell, I can either click play here. You see now the words are PyaR workshop 2025. And so this is super important to be able to print. And one of those things that I was mentioning earlier about Python being the classic language for programming is you can see this is if you want to just print out something inside another language, this is JavaScript, I believe, you can see how complicated it is. But for Python, you just write print and it prints whatever you want. And that's great. And we're gonna move on to our next thing here. And so I'm gonna do this again just to keep this notebook consistent. Now, once again, this is not to say that other languages are bad. I can tell you other languages have their own kind of advantages as well. For example, C++ and Java are super fast. Java is really good when you're doing web designing. C++ is really good when you're doing some kind of machine-heavy things. In fact, Python is written in another language known as C, which was the precursor to C++. So all these other languages, it's not that they're terrible, but they can be used in other things if you want to run something faster. Now, some quick kind of things to watch out when you're doing when you're running this very first function. You can see here the format is that we have everything in that string between the quotation marks. If you do something like this, okay, give me. I'm gonna try to add another cell here. Oh, that doesn't work. Let me not add another cell. Let me comment this out and show you some common mistakes that people make, which is what that note is saying there. So if you do this hello, and then you do this world, you put each one in its own quotation mark, that will give us an error. Oh, did not. Oh, but you can see it kind of not the exact thing that we expect.
Exactly. Yeah. It's
Yeah.
missing
Mm,
that space there.
mhm. And yeah, and those are kind of the kind of things that I think with experience we're gonna see a lot more of these of these kind of things you wanna. But this is not the correct quotation way to put it. I think you wanna put it like this. Anyway, that was just the thing here they were telling you to watch out for. Okay, I'm gonna move on from this cell now. Once again, Python is not only good for just printing out your strings, you can also do a lot of math. You can essentially just use it as a calculator. And so the way you would do that is just writing in your cell, your normal, this is an example of an addition function. So you can just add two numbers here. And if you run that cell, you'll get 4, which is what we expect. And if you do 4 minus 2, exactly what we expect, you'll get 2. And then if this is 4 times 2, where you use the star operator inside on your keyboard, and I don't think there is an actual times operator, but you can use the star, and that should give us 8, which is what you expect. And then you can also do division. This is super straightforward things that you can do with Python, but it's wonderful. And sometimes we want to do this maybe in a super complicated numbers where you can add and divide and do all things. I will talk about the we used to call it BODMAS, but I think people call it PEMDAS here. Yeah, where I learned in in a British system, so we call it BODMAS. But yes, I think what is it called here? PEMDAS?
Yeah. It's
Yeah,
different in
yeah,
different regions. Yeah. Yeah.
yeah.
Yeah, I think
I
it's
was
PEMDAS. Yeah.
also, yeah, I was
Yeah.
also taught under the Bottomless system. So
Yeah,
yeah, it's the same
yeah,
thing.
yeah. Anyway, we'll get to that. So this here is an important function where instead of having one of those star operators, you have two, and so that essentially just gives you a power. So this is 4 to the power of 2, and what do we expect for that? We expect that to be 16, and so that is great. Just another word of caution: you don't want to do this. Let me see. In a lot of other languages probably, and in I think other writing languages, people write a power like this. If you do this, you get 6. Now that looks like it added the two numbers, but not really. This is for what is called a bitwise operator. I am not going to get into that because I don't want to get into analog and electronics and all these things. But essentially, you don't want to do this for 4 power 2. You want to do the two star signs, and that should give you 16. Okay. And yes, that's what that note here was about. And then here, you want to follow, once again, the PEM. I hope I'm saying the correct thing, PEMDAS. But if you're not familiar with that, it's just BODMAS, which is essentially saying that you want to do, it's gonna open the parentheses first, and then it's gonna work on, let me see, bracket opening, and then dividing, and then multiplication, then addition, and then subtraction. So it's gonna follow those mathematical rules. And what do we expect for this here? Oh, sorry. I used to be a teacher, so I am kind of expecting that kind of feedback from students, but I'm just realizing now that that's not gonna be super super easy. But
Yeah.
yeah.
Everyone can, the chat is open for everyone, but please, yes.
Mhm.
I was a teacher for 13 years also. I definitely understand that. And I really appreciate that you're bringing that here to
Yeah.
us. But yes, people can are only able to respond in the chat.
Okay. So if we run this, what do we expect? So if you open the bracket first, you'll get a 3 here, and then this will be 3 times 3 to the 4. I believe we do the power first and not the dividing first. Odd mass. And so that 3 to the 12, the 3 to the 4 is, I don't know what 3 to the 4 is. We can do that on the side. I forgot how to add more cells. Let's do this.
You can just highlight a cell,
Mm.
or like click to the left in the white
Oh,
space area. Yeah, yeah.
oh, okay.
Or
That
also,
works. Or
Mm.
you can
yeah,
just hit B.
Mm.
You can
Yeah.
just hit the B.
Okay. Thank you. Yeah.
yeah.
Three.
And I also like the quick like shortcut to do escape
Mhm.
A. Like if you hold escape A, it usually works.
Nice. Okay. Cool. Yeah. I think I just tried that. So you click a cell and I press A and it just works. Oh, okay. But I don't know how to delete them now. Anyway, we'll just keep them here in my computer, I guess. So 3 to the 4 is
Deleting is just,
Mm.
sorry, deleting is just D twice.
Oh, that did not work for me for some reason.
Uh, Quick
I think
succession, D,
oh
quick succession. Oh, I
yeah.
think it's I think it's clashing with Chrome's shortcuts.
Oh, okay.
Oh, that's
Now-
right.
Yeah.
That's the Chrome. Yeah, there's
Oh,
issues.
okay, yeah.
You got it.
Now,
Okay.
now I lost the entire notebook. Oh dear. Okay, we can restart the cells here. We clear all the answers. Don't worry about this. Okay.
Also, I should take the opportunity to remind everyone that the order in which you run the cells matters, because Python will remember, or rather Jupyter will remember.
Oh, okay, yeah.
So yeah, if you go back and run earlier cells again,
Mhm.
know that it will overwrite anything, any variable names, etc.,
Yeah,
that you might have defined below. So you'll have to run it again. Um, anyway, uh,
in series,
over and
exactly.
out. Yeah.
Yeah. Yes, thank you, Parajito. I was gonna try and mention that when we start doing the variables.
Yes.
Yes, thank you so much. Yeah, that is a good thing. So if you run something here, Python is gonna remember this answer. So you wanna run the cells in order. Okay, so we're not gonna be deleting cells, apparently. So we have 81. So remember, we opened the bracket. It was 3 times 3. So, sorry, it will be 3 times 3. And then here, oh, it won't be times 3, sorry. We're doing 3 to the 4 first. It will be 81. 81 divided by 5. That's 16.2. And so we have 16.2. And so we have 3 times 16.2. That will be 48.2, I'm pretty sure. Let's just do that here. Oh, I did it above. Anyway, so 16 times 3 will be 48. Sorry, 16.2 times 3 will be 48.6. And then once you take out 6, what do we expect here? 42.6. So you can see the way it followed the orders of operation there. And so you want to keep that in mind whenever you're doing math in Python. You want to make sure that you should know that it's following BODMAS rules, and you should write your expressions accordingly. Okay, it's great that we can use Python as a calculator like this, but sometimes you want, or at least most of the time when you're using Python, you want it to remember what is some number, you want to reuse maybe you are multiplying the mass of something, and so you want to set the mass that to equal to something, and so that is when we use these things called variables. And so in Python, now this is one of the quick things that, also one of the first things that you want to understand. This is where things kind of differ with math. This sign here is not an equal sign. I mean, I know it looks like an equal sign and you'd probably call it an equal sign, but it's not an equal sign. This is an assignment operator. What this means here is not A is equal to 1. It means I am assigning A, the variable A, to be 1. I'm going to repeat that again. This is not A is equal to 1. I am assigning the variable A to be 1. And here I am assigning the variable B to be 2. Now, you can use whatever variable names you want. You can use Lordrick. You can use your own name. You can use, whenever you're doing science, for example, you are calculating density. So you let something is equal to mass and something is equal to volume. All those variable names are allowed, okay? But if you want to assign them to a particular number, that's when you use this equal sign. Here it's used as an assignment operator. And now, to show you that that is in fact the truth, let us print out those two things here. So here we are printing A, and here we are printing B. And so once we run that cell, you can see here, this print A statement gave us the 1 here. We assigned A to be 1. And then this print statement here, we are printing B. And so this is a kind of another thing that you
Sorry,
want to notice here.
so sorry.
Hmm.
So sorry to interrupt, but Lordrick, could you zoom in a little?
Oh,
I
okay.
think it will be better for the recording because some people have smaller screens. Yeah, this is
Okay.
perfect.
Is it
Thank
better?
you.
All right. Thank
Yeah,
you so
yeah.
much. Yeah, I didn't realize that. Yeah, I'm okay. That was a little small. Okay. Hopefully this is better. Okay, once again, we've print A and we've print B. Now, another thing I want you to notice here, super quickly, is that we don't have to use print function just for strings. We can also print variables. And so you can see here, this inside is not a string, it's just the number A. But we want to see that answer. And so, once again, we can kind of expand this a little bit. Maybe we want to do math and we want to assign that answer in some variables. And so here we have assigned A to B plus 2. And so when we print A here, what do we expect? We expect that it will print the number 3. Now, an important thing here, once again, Python reads line by line, and so we can reassign that number. Let's say we don't want it to be the result of 1 plus 2 again. We want it to be something else, like maybe 27. We can reassign that. And if we print A again, we should see two different things. And so one of them is that A is equal to 3, and then A should be equal to 27. And so this is to show you that we can, in fact, reassign the variable A. Okay, we can also perform things inside the print function. And so here we are reassigning A. Remember, A was 27 right now. If I print A, sorry, if I print A right now, it will be 27. That's one way to print A, but I don't advise to do that. Let's do this instead. If we print A right now, it's 27. But now we are reassigning A to be 1, and then we are reassigning B to be 2. And so what we expect here is that the print function is going to give us 3. Okay, once again, we can use the comma separated inside the print function if we want to print more than one thing. And so if we print A comma B here, what do we expect? We know A is 2 and B is 1, and so we expect to get 1 and 2. And so here we get 1 and 2 separated by the space. This is just another way you can use the print function. And so kind of one thing you also wanna be careful about is that a string will be printed as is, but operation will be performed on variables if those variables are indeed numbers or they're in strings. We can see operations with strings in a second. So if I say print and then I put quotation marks 3 plus 4, Python is gonna take this string as is. It's not gonna add those two numbers. And so if I print, it will just print the string 3 plus 4. And so that is the thing they wanted you to watch out for. Okay, let's work a little bit more with variables. Python has some of these wonderful shortcuts, and you'll see this a lot in when you're doing loops. Sometimes you just want to add one to the number. Okay, so first we reassign. Let's say we reassign a to be 1. Okay, and then we just want to add 1 to that particular number. Sometimes I don't remember what the variable is. I just want to add 1. This is a way to do that. You just write plus and equal signs. This is the same as writing a is equal to a plus 1. Once again, this is kind of where programming differs with math. In math, this would be an equation with no solutions, but this, once again, in Python is not an equal sign. And so what do we expect? I would love to see the chat here to see what people expect with this thing. But essentially, what you expect is that a is 1 in this case, and so 1 plus 1 should be 2. And so we expect first to print 1, then to print 2 for this amazing operation here, and then a star equal 3. This means just a is equal to a times 3, and so this should give us 6. And exactly what we expect. And you're gonna see a lot more uses for this kind of notation when you're doing loops. Okay, this is another fun thing that we can do super quickly. We can do a lot of other things with these things. Now let's get into the data type called strings. And so here we are assigning this variable s, which makes sense because we're working with a string, to this string here called hello world. Okay. And so here, I'm going to comment this out in a second so that we just see what happens there. So if we print s here, we should see hello world. Nice. Okay. So this is now, we can assign essentially anything to be a variable. You will see in the future, we can even assign a function to be a variable. And that works out just as well. And okay, so you can see here there is something written as dot lore. Okay, this is another one of those functions, but this is a special kind of function because it's working on this string. Now, once you get into the depth of object-oriented programming, you'll learn that this is in fact something called an object. The good things about object is that we can also work on those things. And so this thing here called lore is essentially gonna work on this object here known as a string. And this is essentially just gonna turn every word that's in uppercase to be lowercase. And so let's see if that is the case. So you can see the first statement here, print s, should print the same thing as hello world, but s.lower should make the h and the w lowercase. And exactly as expected. You can also do that for uppercase, so sometimes you just want everything to be uppercase. So first we're printing s, and then we're printing s lower, and then we're printing everything in uppercase. Amazing. Okay, we have hello world in uppercase. We can also replace words. And so here we have s.replace, and this is essentially saying replace the word the first variable in this function here. So we can also add things inside functions. We'll see a lot more of that later, but it's saying replace the word world, which is the first thing here, with the word zip. Okay, let's see if that works out as we expect. Exactly. So you can see here the word world has been removed and we have replaced it with the word zip. And this is the point where I encourage everybody, just play around with these functions. Play around with this is how you kind of learn. And to me, it's kind of fun as well. Just play around a lot with these functions and you can make them do a lot more things. The good thing about programming is that different people come up with different things and they make a lot of beautiful things. So as I was mentioning earlier, you can do operations with strings. So here I have s. We have assigned s to be hello world here, and we are gonna add hello world. It's a beautiful day. And so we have made a new variable called new string. We're gonna print this variable called new string, and new string should essentially be hello world, and it's a beautiful world. Okay, I'm gonna comment out this second one first so that we can see if that's exactly what to expect. Oh yes, it is exactly what we expect. We can also multiply strings. Okay, so this will be hello world times 2, so it should be hello world, hello world. Let's see if that is the case. Yes, that is indeed the case. It is hello world, hello world. Amazing. So we can do Matthew strings. Practically, I don't know if I've done this a lot. I've only seen kind of the seed in tutorial, but I don't know. Maybe you'll come up with a program that needs to multiply some strings. So go for it. All right, and now we get into another data type. I am gonna take 1 minute here just to kind of people to absorb what I just said, so that I can get into data types, into other data types.
And we have 5 more minutes for your section, Lordrick, to take
Okay.
list and tuples, and then we'll be ready for a PyR 2.
All right, so we only have list and tuples left.
Yes, the PyR is going to pick up with conditionals and booleans.
All right. All right, that's amazing. Okay, so I'm gonna try to go through this quickly but concisely as I can.
I think
Yeah,
you can keep the sorry, you can keep the tuple section brief because I don't think we use
tuples.
tuples in the
Ah,
later notebooks. So yeah, just to introduce it. So
yes, I think I can just quickly
yeah,
just
yeah,
kind of introduce them in a way. But lists are
yeah,
like super important, so we
yeah, absolutely.
yeah, we can go. Okay, let's get into lists. This is an important data type because sometimes we want to store data types into other data types. And I mean, not just that, but we want to store, essentially, you just want to have a list of things. And a list here is just essentially the same as your list of groceries. It's just a list. It's just a list of things. And so we can have a list of strings. We can just have a list of numbers. Now, one quick thing I want to mention here in Python, there are different types of numbers. They are what we call floats, and then you have ints or integers. And basically, integers just don't have a decimal point, and floats have a decimal point, and these kind of behave a little differently. I'm gonna leave that as a homework to the beginners here. Just kind of go and see those differences. But it's important to know that in Python, we essentially don't just say numbers. So, for example, here I would say I have a list of integers, or a lot of people you hear them say I have a list of ints. And so let me comment this out. So here I'm saying I'm assigning the variable x to this list of integers here. And so let's print that out and see what happens. Oh, exactly. Now, what I want you to notice here is that a list is just made up of whatever you want in the list, and you want to put that inside square brackets. This is very important. A list is square brackets. Now, you'll learn other data types when you keep going. For example, tuples or tuples, however you people pronounce them, they are put in parentheses. There's, for example, dictionaries, which I use dictionaries a lot. These are great data types. You should definitely learn those sometime after we finish this workshop. We put those in curly brackets. But for now, we're learning lists, and so I want you to keep this picture of square brackets in mind. So when we put anything in square brackets and we separate it by commas, that in Python is what we call a list. Now, why are we so hyped up about these lists? Is that we can do a lot of things with lists. So say I just want this number. I just want to get this very first number. Now, here's another important thing in Python is that Python is what we call a zero index language. A zero index language means we don't count things from one as one would in normal life. We count things from zero. And so this first item here in your list is not called the first item, it's called your zeroth item. And then the second one is called your item in your first item or your item with index one. And then you'll have another item with index two, and then you'll have another item with index three. And so let's say I just want this first item, which in this case, it's zero. And so if I print X and then I print X of zero, I should expect just a zero down there. And that is exactly what we expect. And so this is not the only thing I can do with this is not the only kind of list I can make. Let's make another list. Let me call it J. Okay, just another variable. And let me copy this. And let me put that there. And let's say this first things, I don't even want it to be uh an object. Let me make it a name. Let's say Lordrick. And then I want us to print the very first item in that list. So we want the 0th index. I also put that. So another thing that you can kind of notice here, when I'm indexing, this is called indexing. You refer to the index, you put it in square brackets. And so I want the 0th item. And so if I print, what do I expect here? I expect to see the string Lordrick. That is indeed what happens. And so if we come back to this cell here, we can print the first item, which will be 1. Okay, great. So 1 is printed there, and I can also show you the other items here. Great. So this is how we index. So we can refer to any item in the list using just this indexing method. And list can be as long as you want. List can have 1,000,000 items in there, and it can have 1,000,000,000. And so what happens? Before I get into that, how do you know the length of the list? Essentially, how many items are in the list? So I can just try to print here. And this is once again the print function. You can see here we have one string that says length of, and then we have comma length of x. This is one of those wonderful ways we use comma inside the print functions. You can see we want to print a string here, and we want to print the length of x. And so to print the length of x, we use this function called len. So you just write len. Remember, x is this list. How many items are in here? 1, 2, 3, 4. So what we expect here, it should say the length of x is 4. If it's not 4, I will be very sad. It is indeed 4. That's great. So that is how we know the length of a list. Once again, a list can have any length, as I mentioned before. But if your list has, I don't know, 300,562 items, and you just want the last item, you're not gonna have to write 3,562 here. You're just gonna write -1. And so this -1 index is essentially just the very last index. And you can kind of imagine -2 index will be the second last, -3 will be the fourth last, will be the third last, and then -4 as far as first. So what do we expect here? At least I expect to see 3, 2, 1, 0. Let's try that. Amazing. 3, 2, 1, 0. So we can index a list essentially from the end of the list just by using negative indices. And now, another thing that we can do with lists is called slicing. Now, say I want more than one thing inside the list. I just want a couple of items. Let's say I want, so this is called 0 up to 2. Now, here's another important thing. Let me first comment this out. And oh, I wish this was a classroom so that I could do this in front of class and just ask, what do people expect here? Anyway, so this is the 0th index to the index number 2. Now, I know, at least when first I saw this, I thought maybe I'm gonna get the 0th index and the first index and the second index because it's saying 0 and put a colon here. This colon just means all the way to 2. I was like, oh. But then Python is what we call an exclusive language. It includes the lower index, but does not include the upper index. So this is the lower index. This is just some more terminology I'm throwing at you, and this is the upper index. It does not include. So essentially, this is saying giving me everything from 0 all the way to 2, but not 2 itself. And so what I expect here is just to see 0 and 1. Okay, let's see what happens when we do that. Oh, amazing. So we have, this is why it's called slicing because it means like we're slicing the list essentially. We're cutting it into a piece. And so yeah, once you can see that we can try that. Okay. Now if I want all the way up to the second index, so I'll say from 0 to 3. Okay? Remember? 3 is gonna index the fourth item here, and 2 is indexing the second item. But we don't want the fourth item. We want all the way up to the third item, which I think maybe kind of makes sense that we just want third item. So it will have from 0 to 3, and sometimes you don't want to write the 0 here. You can also just put a colon here and tell it to go all the way to 3. It is the same as it will, when Python sees this, it just assumes that the first index is indeed 0. And so we should see the same thing. Amazing, we do see the same thing. And so maybe sometimes you want, this is kind of just, this is where I encourage students to just go and play around. Maybe sometimes you want one, and then if you don't put anything in the upper index area here, it's just gonna assume you want one all the way to the last index. So I should expect to see 1, 2, 3 here. Amazing, we do see in 1, 2, 3. And then you can also, play around even more. You're gonna be like, I want for so once again, when you don't put anything here, it assumes this is zero, but this is essentially going from zero to the second last item. This is when you're being very, very fancy. And let's see, what is the second last item? I forgot where the list is. Yes. So, let's see what happens when we do that. Amazing. So the second last item here was indeed 2, but once again, Python is upper index exclusive, so it won't give you that second last item actually, it will give you the one before that. And so that's this is what you get. So you can play around with that as well. And this is one of the you can see like here I'm just having fun putting indices, but we do this a lot in programming. We do this a lot when we're working, especially when we're doing linear algebra or something like that. We do a lot of indexing, and I think at some point maybe you will learn about arrays where they can be two-dimensional lists with one data type, but I don't want to get into that at the moment. But we do a lot of indexing and a lot of slicing. And so here's another fun thing you could do. We have our list here. We have now reassigned X to be the list 1, 2, 3, 4. If you print that, you'll get 1, 2, 3, 4. But let's say we want the ones index to not be 2 anymore. This is the number in the ones index. Once again, be very careful. Python is 0 index, so this is the zeros item. This is the ones index. And so we want that ones index to not be 2 anymore, to be 486.1. This is an interesting number. I don't know why this one was chosen. But yes, let's try that. When we print, you can see here the first time the X used to be 1, 2, 3, 4. But once we replace the second number, which is index number 1, to be 486.1, you can see the second X is now 1, 486.1, and 3, then 4. Okay, lists can hold a lot of things. I think I've said this. I've shown this in my example implicitly there. You can also put a string inside a list. But here is the crazy thing: you can put a list inside a list, and it will still work fine. So here we are assigning a, the variable a. I believe last we had of a, it used to be 1. Let me see if that is the case. Oh, it's 6 now. Okay, yeah, I think we did a is equal to a times 3 or something when a used to be 2. A used to be 6. And now we are assigning a to this variable here, okay? And so this variable will be the list that has the number or the integer 1, and then second is a string, and the third index is a list. And so let's see if we can see that before I get into this. Okay, it is indeed A is now indeed a list. This is the first line here. It's the first line here, and we can index the first item, we can index the second item, we can index the third item. Now, here is where Python gets cool. We can index something if it's a list inside a list. And so here you can see this last line here is saying that inside A, give me the third item, which is an index number 2. We know that third item is a list. Inside that list, give me the very first item in the 0th index. And so what do we expect here? The last print statement should give us 1, and voila, we have 1. So this is one of the cool things about Python. All right, so maybe you're like me and you're lazy and you don't want to write your lists in 1, 2, 3, 4. We can use functions. And so before I write that, let's see what this range function is. Let me print, should I print range? So this range function, how people use this is where you want to start, okay? You want to start with the number 1, and then The second number means we are ending here. Remember that Python is an upper index exclusive language, so this is not gonna end in 10, it's gonna end right before 10. But you can see here we have something else here, and I'm gonna let you guess what you think this other thing is. Oh, but before that, okay. Let me just print the list so that you can see what I mean, and then we can talk about range later. That cool function there. Let me print this list. Now, another thing here. Oh, that's why what happened I didn't expect. We have to make it a list. Okay. And so here we have, if we want to make anything a list, so here range is just a function. I think I'll let the parameter, maybe we'll talk about functions a little bit later. But we can make anything a list, okay? The output of this function will be this list here. And if I print that list, it gives us the number 1, 3, 5, 7, 9. And so if you notice very quickly here is that what this range thing is doing here, oh, sorry, my Grammarly is getting in the way. What this range thing is doing here is essentially saying that I'm gonna give you all the integers starting from 1 all the way up to 10 in steps of 2. Okay? And so that means it starts with 1, 1 add 2 is 3, 5, 7, 9. And so you essentially get all the odd numbers. And so we can do this again. Let's try to print a list. I'm gonna be fancy a little bit here. From range, let's say 1, no, let's say that with 2 to 10 again in steps of 2. What I'm expecting here is that I should get 2, 4, 6, 8. Remember, Python is upper index exclusive, so we won't get 10. Let's see. Oh, okay. I haven't finished my brackets there. Okay, and this is a good point to tell you.
Yeah.
Errors are not the word. Don't be scared of errors. Okay? In fact, most of your life when you're writing code, you will get errors. Okay? Don't worry about them. You just have to understand them and fix them. For example, this error was literally showing me that there's something missing here. Okay? Which means I have to add one more bracket. So do not be scared of errors. Okay? I can't believe it took me this long to mention this. Do not be scared of errors. Errors are great. We just fix them. And actually, most of the time in writing code, you will get errors until you don't, then you are done. Okay? Basically, what we do as programmers essentially is just solving all the errors all day. And so if we print this, oh, it's still saying that I don't have enough. Oh, I still need one more bracket. Amazing. Okay. And so now we've added one more bracket. That should work. And so here we have our list as we expect. And so there is other fancy ways. Here you will just, if you do range of 5, it should give you 0, 1, 2, 3, 4, 5. It will assume all the other things. It will assume you're starting from 0, you're ending at 5, and then it will assume a step of 1. And so if we print y, where you're saying y into the list of it, it should be 0, 1, 2, 3, 4. And so let's see that. Amazing. Okay. We can add we can add two lists together. And so remember, y is 0, 1, 2, 3, 4. And then where is x? X is 1, 3, 5, 7, 9. When we add this together, it's not going to be what you expect. Let's see what it is. Oh, it concatenated the lists. Okay. Later you'll learn about another data type called an array, which will do what I think what probably most people would expect is that it will add these numbers together. That means to add the 1 to the 0 and the 3 to the 1, all that type. But for lists, when we add, it concatenates. And so once again, much like a string, we can also multiply lists. And so this should give us the list y twice. And so if we do that, that is essentially what happens. Okay. So we can assign the variable as well into another variable to be an operation of list. So here once again when we add x plus y, it should be this thing. And if we print we can print that. And then there is this sort function, which is another funny thing I'm gonna mention very quickly here is that we can arrange the numbers inside a list. And if we print that, it should give us that very same list, but now arranging the numbers from in ascending order, which is a great thing we can do with lists. We can also add things to lists. These are some of those things which I want you to just I'm just introducing to you, and you can just have fun with them by yourself. Okay. And so here, essentially, we have a list called X. We assign the variable X to the list 3, 2. And so once I append 1, I should expect the list should now be 3, 2, 1. And then I can append 0 again. Let me append 1 first. Okay, so now you can see we print X, and X is 3, 2, 1. But we can also append another number, 0, and it should be 3, 2, 0. Okay, I know that was a lot of information, but don't worry about it. Once you start playing around with the notebook, it will be super, super, super clear. And now, very quickly, I'm gonna mention something called a tuple. This is a lot like a list, uh, except the first thing is that you put it in parentheses. And the second thing is that we can't change things inside a tuple. Okay, so it works a lot like a list. For example, here, if we print letters, it will be the list A, B, C. Sorry, not the list. Sorry, the tuples A, B, the tuple A, B with the elements A, B, C. And once again, we don't call these items inside tuples. We call them elements. And then, if you want to refer to the second element, this is yeah, I'm just using it the same way we do with lists in square brackets, and you'll get this second element. But if you try to change something inside a tuple, let me try letters. Let me say I want to change that B. Sorry, the second element B to be something else, to be baby. Let me put it in a string, baby. It will tell me, no, 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 no. You're not allowed to do that. You're not allowed to change things inside a tuple.